Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 7th, 2026, about 2 days ago. It introduces a new dual-path framework called Atlas that outperforms closed-source models like GPT-4o, surpassing existing routing methods by over 10% on in-distribution tasks and 13% on out-of-distribution tasks. The paper is titled Atlas, Orchestrating Heterogeneous Models and Tools for Multi-Domain Complex Reasoning. And as we'll see later, the way it combines clustering with reinforcement learning really pushes the boundaries of autonomous agent capabilities. Figure 1 maps out the different paradigms for large language model inference and highlights the specific limitations that this paper aims to address. On the left, we see that direct inference can be imprecise on complex tasks like chemistry, while tool-augmented inference is accurate but relies on rigid, static logic. Shifting to the right side, standard query-based routing offers efficiency, and reinforcement learning provides power, yet they typically function in isolation. The bottom right panel frames the ultimate challenge, creating a hybrid reasoning engine that unifies these elements to solve high-dimensional optimization problems. Well, Figure 2 proves that this hybrid approach pays off. It compares performance across two settings: familiar, in-distribution tasks on the left, and novel, out-of-distribution tasks on the right. In the left panel, the pink bars represent the cluster-based Atlas model. It secures the top average performance, beating even GPT-4o because it efficiently leverages historical patterns. But look at the right panel for out-of-distribution scenarios. Here, the purple bars for the RL-based model dominate, especially on difficult benchmarks, like AIME25. This confirms that while clustering handles the known well, reinforcement learning is essential for generalizing to the unknown. So, Figure 3 breaks down the architecture behind those results. The top row illustrates the training-free, cluster-based routing, which handles domain-specific scenarios. It works by embedding the user's query into a semantic space to find the closest cluster, then instantly retrieves the optimal model tool combination based on past performance. Meanwhile, the bottom row details the RL-driven multi-step routing for open domain tasks. Here, a policy LLM orchestrates a reasoning loop, dynamically selecting resources from a routing pool and refining its strategy through reinforcement learning updates. Alright, having seen the architecture, Table 1 now lists the specific performance metrics across diverse domains, ranging from math and code to common sense reasoning. The top rows display benchmarks for closed-source giants like GPT-5 and GPT-4o, which sets a high bar. Notice that GPT-4o averages about 53% accuracy here. Moving down to the in-distribution performance section, the cluster-based Atlas model clearly pulls ahead. It secures an average of 63.5%, beating the best prior router DC by over 10 points. Finally, the bottom section highlights the out-of-distribution results where the RL-based Atlas model shines. It jumps to nearly 60% average accuracy, delivering massive improvements on difficult math benchmarks like AIME25 compared to the cluster-only approach. So, Figure 4 shifts the focus to multimodal performance, comparing Atlas against rigid, single-tool baselines. The horizontal axis lists datasets like CQA for charts and GO3K for geometry, while the legend identifies specialists like QN3 chart. In the middle GO3K cluster, we see that general models struggle while the specialist performs better. However, the purple bars consistently rise to the top because the system dynamically swaps tools. This advantage is clear in the average group on the far right, where Atlas leads the strongest individual models. Wrapping up, two main points stand out: the shift from model scaling to ecosystem orchestration, and the effectiveness of dual-path routing. This research proves that intelligently coordinating smaller, open-source models can actually outperform massive proprietary systems, like GPT-4o. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.